Hello children, this is the second video on chapter 1 of real numbers. Hope you children watched the first video on the number systems. So continuing with the real numbers, in this video I will be taking up Euclid's division lemma. Let's get started. In order to explain the Euclid's division lemma, I have taken the puzzle that has been given in your NCERT textbook. And I am trying to explain to you how we solve this particular question, this puzzle. So there is a trader who is selling eggs, and he has an wordy duel with an idler. This grew into a fight, and the idler pulls the basket with eggs and dashes down onto the floor. The eggs are broken. The trader requests the panchayat to ask the idler to pay for the broken eggs. So the panchayat asks the trader how many eggs were broken. Now the trader, instead of giving a straightforward answer, says this. That is the number of eggs when they are counted in pairs, 1 remains. When they are counted in threes, 2 remain. When they are counted in fours, 3 remain. And you see as it goes on. But when they are counted in sevens, nothing remains. And he also gives you one more clue, that is the basket cannot accommodate more than 150 eggs. And we have to find out what are the number of eggs. So in order to solve this, what we do is I'm taking let the number of eggs be A. So if you read this last sentence over here, last sentence, if counted in sevens, nothing will remain. That gives you the hint that the number A, number of eggs, is going to be a multiple of 7. So I have written A is equal to 7p. But when it is counted in sixes, the same A, you will say, because 5 will remain, A is equal to 6q plus 5. You have to use different alphabet over here, different variable over here, because they are all varying. You don't know, each one is going to be a different one. So here when they are counted in fives, A is equal to 5r plus 4, because 4 are remaining extra. So this is how we get we are able to write the equations, and I want to find out what is my A equal to. Also given to us that cannot accommodate more than 150x, meaning A is less than or equal to 150. So I take this A is equal to 7p as the starting point. As we had written in the previous slide, these were the conditions. That is, A, the number of eggs, is a multiple of 7. If the same number is represented as 6q, then 5 is the remainder, and so on. What I do is, since A is less than or equal to 150, I start with 150. Since 150 is not divisible by 7, 150 is definitely not A. Similarly, 149 is also not divisible by 7. 148 is also not divisible by 7. And therefore, my A, the number of x, cannot be 148, 149 or 150. But when I come to 147, you see that 147 is divisible by 7. That is, 147 is equal to 7 into 21. But 147 is equal to 6 into 24 plus 3. But I want plus 5 over here, which implies that 147 satisfies condition 1 but does not satisfy condition 2. Therefore, 147 is not the required number of A. Now, by trial and error method, we find out the number 119 satisfies all the 6 conditions. You see, 119 is a multiple of 7. When 119 is equal to, you divide 119 by 6, you will say 6 into 19 plus 5. So my second condition is also satisfied. 119 is equal to 5 into 23 plus 4. That means this condition is also satisfied. 5 into 23 plus 4. Similarly, you see 119 is equal to 4 into 29 plus 3. That is my fourth condition is also satisfied. 119 is equal to 3 into 39 plus 2. That means my fifth condition is also satisfied. And 119 is equal to 2 into 59 plus 1, which implies that my sixth condition is also satisfied. That therefore I am able to say clearly that 119 satisfies, or 119 is the number of eggs that the idler broke, or the 119 is the number of eggs that the trader had with him. Now consider in order to further explain Euclid's division lemma, consider the number 73 and let us divide 73 by 5. What do I find out? When I divide 73 by 5, I will find out my quotient is equal to 14 and my remainder is equal to 3. If you look more clearly, you will see that 73, that is the dividend, is equal to divisor into quotient plus my remainder. So dividend is equal to divisor into quotient plus remainder. This is something that you have done in your 8th standard and in your 9th standard also. So from here, I get the division, Euclid's division lemma is written as: given positive integers a and b, there exists unique integers q and r satisfying a is equal to bq plus r, where 0 is less than or equal to r is less than b. So a is equal to b into quotient plus remainder, where your remainder is always going to be 0, between 0 and b. It can be equal to 0 but it will definitely be less than b. So you see over here, this is your r, this is your a, this is b, and this is q. So you see that r is always going to be less than b, because if this r was more than b, then obviously your division is not, your quotient is not correct. So here the question is to find the HCF of 2048 and 960. What we do is that we are going to successively use the Euclid's division lemma in order to find out the HCF. This successive application of the lemma is called the Euclid's division algorithm. So let me first explain the procedure to find out the HCF of these two numbers. So 204, what we do is first we find out what is the bigger number, 2048, and you will say let a is equal to 2048 and b be equal to 960. Then I will write down 2048 is equal to 2048 is equal to what? 960 into dash plus dash. So what we do, we will divide 2048 divide by 960. You will see that 960 into 2 will give me 1920, and therefore here my remainder comes out to 128. So you remember I had said if this is equal to A, and if this is equal to A, and if this is equal to B, this is equal to Q, and this is equal to R, then my A is equal to BQ plus R. So I will write down over here 2048 is equal to 2048 is equal to 960 into 2. This is 960 into 2 plus the remainder, that is coming to 128. Then I will take 960 is equal to 128 into dash plus dash. Okay, let's fill up that now. 960 and I'm dividing by 128. So what is my quotient over here? It comes out to 7. So I get over here 896, and my remainder comes out to 64. So this is going to be 128 into 7 plus 64. So this is 128 into 7 plus 64. Now again I will write down 128 is equal to 64 into dash plus dash. So this 64, 64 into 2 is equal to 128, and therefore I will say into 28 plus the remainder is 0. That is, if you do 128 divided by 64, you will get to 128 and remainder is 0. So you have gone up to, you get the value of remainder 0. Now we say that, we claim that 64 is the HCF of 2048 and 960. So you see that I have successively used the lemma 3 times in order to find out the HCF, that till we come to the remainder to be equal to 0, I am doing this successively in order to get the remainder equal to 0 and to find out the HCF of 2048 and 960. So with this in knowledge, let me now write down the division algorithm. The successive application of Euclid's division lemma is called the Euclid's division algorithm, and it is used to obtain the HCF of any two given numbers. To find the HCF of two positive integers c and d, with c greater than d, we will follow the following steps. That is, first you will apply Euclid's division lemma first time. If the remainder is equal to 0, then your divisor d becomes the HCF, and if it is not equal to 0, then we again do the division lemma till we get the remainder to be equal to 0. So this is one more example that I have taken to find the HCF of 1260 and 7344. The first and foremost condition, many times children get confused because when they see the first number is 1260, they write down A is equal to 1260. But no, please remember over here that here your 7344 is greater than 1260, and therefore we will take A to be equal to 7344 and B to be equal to 1260. So let's start with this sum. We will say over here, this 7344 is being divided by 1260, and I get, when I divide it by 5 times, I'll get over here 6300. So this will be 6300, which is less than 7344, and therefore my remainder comes out to 1044. I will fill in this part over here. This is going to be 1260 into 5 plus 1044. Then now I am going to write down this 1260 comes here and 1044 comes here. I use a different ink so that it's easy for you to see. So let me do this. This is 1260 comes here and 1044 comes here. So now this is, I am going to divide 1260 by 1044. And I get, it goes only one time, so 1044, and my subtraction when I remainder comes out to 216. So here it is going to be 1044 into 1 plus 216. Further again, we will bring this 1044 is to this place and 216 to this place. So I will get, now I am going to divide 1044 by 216 and I get, it goes 4 times. So I will be getting and 864, and therefore I am going to get 0, and this will give me the remainder as 180. So here my fill in the blanks will be 216 into 4 plus 180. Now I'm going to do the division, that is 216 this time divide by 180. When I divide by 180, it goes only 1 times and my remainder comes out to 36. So this is going to be 1 and this is going to be 36. Now my 180 comes here and this 180 comes here and this 36 comes here, and you will see that when I do 180 divided by 36, it goes 5 times and I'll get 180 and my remainder is equal to 0. That means over here this is going to be 5 plus my remainder is going to be equal to 0. And therefore at this point I stop. At when the moment I get the remainder to be equal to 0, I stop and I write down the HCF of 1260 and 7344 is 36. So this question is a CBSE question, and here we are being asked find the HCF of 65 and 117 and express it in the form of 65n plus 117n. Now what is this it? You have to express the HCF of 65 and 117, which means that first of all I have to find the HCF of 65 and 117. So we will say let A is equal to 117 and B be equal to 65. We'll say 117 is equal to 65 into 1 plus it will come to 52. Then we will say 65 is equal to 52 into 1 plus 13. And then we get 52 is equal to 13 into 4 plus 0, which implies we will be able to write that HCF of 65 and 117 is 13. Now we have to write 13 in the form of 65m plus 117n. So I will name this as 1 and I'll call this as 2. So you see from 2 I get 13 is equal to, you see over here 13 is equal to 65 minus 52. So I'll write down 13 is equal to 65 minus 52. Then further from 1 I get 13 is further equal to 65 minus 52. I will write as 117 minus 65. So I'll write this as minus 117 minus 65. When I simplify this, this will become 65 minus 117 plus 65. So this will become 65 into 2 plus 117 into minus 1. So I have managed to express the HCF as 65 into 2 plus 117 into minus 1, and therefore my M is equal to 2 and N is equal to minus 1.